All right, let's continue in section 6.2. Let's look on page 371 in your textbook. Look at problem number 16. Let's try that one out. The third root of 9 times the third root of negative 24. And just a little side note, if you plug this into Wolfram Alpha, it will give you a different answer than what we get. That's okay. It's just interpreting the third root of negative 24. There's actually 3 different answers there. We're going to do the easiest one here. There are other ones. So don't worry about that. Go ahead and try to simplify this. Pause the video. Okay, we're back. Let's see. 9 times negative 24. That's going to be, oh, what is that? 9 times 24. Let's see. I was about to get my calculator out. How weak am I? 18, 19, 20, 21. So that's the third root of negative 216, and that's just going to be negative 6. Whoops. Okay, that goes evenly. I have my power chart. I look on my power chart. There's 216. Third root of 216 is just 6. Because it was negative, it stays negative. Does that work out? Negative 6 times negative 6 times negative 6? Yes. That gives me a negative 216, so that's good. Let's try number 20 next. The third root 81x cubed. The third root of 81x cubed. And don't let that 81 fool you. It's a perfect square, but is it a perfect cube? Go ahead and pause. Okay, let's see. Of course, it's not a perfect cube, right? Let's see. We're going to have the third root and the third root, and this is going to be my good pile, and that's going to be my leftovers over there. So let's look at the cube roots. Let's see. We're going to have 27 here. Okay, I know 3 goes into 81. It's 9 times 9, and out of if you kind of break that up a little bit, you have 9 times 9, then 9 times 3 times 3, and between the 9 and the 3 there, you can get the 27. That's on your chart here. So that's mentally how you can kind of break that number up to get to the 27. So 27 and 3, but x cubed is a perfect cube, so I can put x cubed there. Well, that's pretty cool. So the third root of 27 is 3. 3 divided by 3 is 1 times the third root of 3. So that's number 20. Okay, let's try one more. 36. Okay, this is 3. Some coefficient up front. We're just going to drag it along, kicking and or screaming. Times the fourth root of 18a to the 9th. Times the fourth root of 6ab squared. Okay, the fourth root of 18a to the 9th times the fourth root of 6ab squared. Go ahead and try that out. Okay, we're back. First thing I'm going to do, these are both fourth roots, so I can multiply them together. 18 times 6, 18 times 6, see that's 48, 4, that's 108. A to the 10th, b squared. Now let's look at our perfect powers of 4 and see if any of them go into 108. So, gosh, the only one I have to check is 16. 108 divided by 16, does that go evenly? 108 divided by 16, no. Because to be 16, it would have to divide by 4 twice, right? Because 4 times 4 is 16. So 108 divided by 4, let me see, that would be 27, and 27 doesn't divide by 4. Okay, so no. So there's no perfect fourth power that goes into 108, and that's okay. So let's get our 3 out front. Let's get our good pile here. Let's get our leftovers. So the whole of 108 is just a leftover. Okay, a to the 10th power, what's a number less than 10 that will divide by 4? It's going to be 8. And I'm going to have 2 left over. And 2 divided by 4, there's no hope. So that all just goes into the leftover. So if the number is less than the index, if the exponent is less than the index, it just goes over here. So the only thing I can do here is 8 divided by 4 is 2. And that's all you can do. So 3a squared times 4, and then 108. I'm sorry, 3a squared times the fourth root of 108 a squared, b squared.